Hello, linear algebra student. This video is for chapter 1.6 again, part 2, and we'll work on the third work problem, which is network flow. What is a network? A network consists of sets of points called junctions. You can think of it as rows. Cars coming in and cars leave this junction and goes out. We call the junction called nodes, and those branches that branch out or lines or arcs. So the basic assumption is just think of car situation. The junction is the road junction. Is the total flow into a network equal to the total flow output, and also the total in a junction equal to total flow out of the junction. So car coming into a junction, they either have to turn left or right, they have to go straight, right? So in this particular case, the junction, the arrows coming into the junction is the inflow, and the arrow, anything that flow out of the junction is outflow. So the outflow is x1 plus x2. You can think of a car coming in, they either has to go the first branch or the second branch. So add together is equal to 30 if you have 30 cars coming in. So the problem of network analysis is to determine the flow in each branch when you only know how many cars are coming in or out. So this is an example of a network, a traffic flow, and we only know that there are 300 going out from this street and 400 coming in. And this particular one, it seems like it's one-way row. There will be 300 coming in and 600 going out. So, and then there is 100 coming in, 500 coming in on this. So what would be x3? So the first one is actually really easy to do. So all these outside control the flow into this big network. So the total flow into is 100 here. And just look at outside, which one is going in? 400. This is out. 500, right? And these are coming in, and the 300, this is going out. So this is total flow into. The total flow out would be anything you have outside that's going out. So it's the x3. Go out is the 600, right? And also this go out of 300. So if you solve this, you would see that x3 is actually equal to, subtract everything, is equal to 400, because x3 would equal to, all of these add together is 1,300, right? And this is x3 plus 900. So we would have x3 equal to 400. So this is something that is known. And the other things that is known is each junction. In each junction, if you look at junction A, I have 300 coming in and 500 coming in, but they go out to x1 and x2. So this is the equation. And function B, which one is coming in? Is x2 is coming in, x4 is coming in. They flow out to x3 and 300. Junction 3 flowing in is 100 and 400. Flowing out is x4 and x5. And then junction D would be flowing out is 600. Coming in is x1 and x5. So these are all the information that you have. And if you summarize them together, so for example, x1, x2 is equal to 800. This intersection A would become the first equation. The intersection B, you can move the x3 over and leave the 300 on the other side. So you have the second equation. The third equation will be x4, x5 equal to 500. So you want to have all the x positive as much as possible, or actually all the numbers on the other side. So all the variables on one side. The last one is x1 and x5 equal to 600. And really the last one is the one that we find out using the total flow. x3 is 400. So if you do this, then it become an augmented matrix of 1, 1. We have 5 unknown, right? 1, 2, 3 more, and 800. 0, 1, negative 1, 1, 0, 300. Another one would be 0, 0, 0, 1, 1, 500. And then the next one would be 1, 0, 0, 0, 1, 600. And the last one was just x3, right? A 0, 0, 1, 0, 0, 400. If you want to, you can no, you cannot rule out. Can you rule out? No, you should not rule out x3. Some people would put in x3 and then simplify it, but I think it's not needed, so it's not necessary. Just do it. And then we do a row echelon form of this matrix, and I have entered this matrix into my calculator right here, right? Uh, no, is that the one? Right, right. How come it's different? Hmm. Is it the one that I use? Um, maybe not. I have 800, 300, 500, 600, 400. The 400 seems wrong, right? So the 400 should be 0, 0 here, right? 1, 1, 1, negative 1, 1, 1, 1, 500, 1, 0, 0, 0. Yeah, the last one is just x3 equal to 400. And then I do a reduce row echelon of C, and you can see that there's a free variable. And I would have the first row is equal to 1, 0, 0, 0, 1, 600, 0, 1, 0, 0, negative 1, 200, and then 0, 1, 0, 0, 1, 0, 0, 400. The last one is 0, 0, 500, 0, 0, 0, 1, 1, 500. And then the last row is all 0, 1, 2, 3, 4, 5. That has 6, right? 6 column. So, so this tells us that x1 is equal to 600 minus x5. x2 is equal to 200 plus x5, right? x3 is equal to 400. That's what we have done before. x4 is equal to 500, also minus x5, right? And that's it. And x5 is free. So can we actually allow anything for x5? We should not. So in order to make sure that x1, 2, 3, 4, 5 are positive, that we don't switch the arrows, so what we should do is make sure that all of them are positive. That means what is the least possible value that can happen to make all x1, x1, x2, x3, x4 to be positive? That means 600 minus x5 is greater than 0, so x5 has to be less than 600. And from here, x4 also 500 minus x5 also has to be greater than 0, right? So the least possible, this would limit that x5 has to be less than 500. Can it be equal? I think so, right? So this limits the free variable of x5. And you can also do more analysis. So as to say that, okay, if this is less than x5, what would be the minimum for x1 and x2 like that? Okay, so that is how you solve the network problem application.